Hey Gavin, indeed. If you're just now joining us, we were working on, in the back of our homework spirals, a quick quiz on 4142. So go ahead and pause this video and try those answers, and we're just about to go over the answers. On the backboard are the multiple choice solutions, BBC for 1 and 2 and 3, and we're about to go over the FRQ response. Alright kiddos, any questions on the multiple choice besides the fact that I totally made a mistake on number 1? That's going too fast. BBC, we're good? Okay. So we're going to start going over the FRQ. And to go over the FRQ, let me get a quick extra page. You guys should have a colored pen out for this part, right? Have you seen where you made a mistake, etc., etc., etc.? So for the free response, let me go ahead and make it huge so I can see it as we work it out. Alright. You have an implicit curve. There we go. Finding dy dx shouldn't have been too bad because you guys were doing product rule, right? And so we have our second d first, which would just be our y squared. We have our first d second, which would be our x times, I know it's awkward, but that's alright, 2y dy dx. And then we have our minus to distribute that negative. Second d first would be our 3x squared y, and then another minus, because of the product rule, that the subtraction would distribute. First d second, which would be our 3x cubed times our dy dx, equals 0, derivative of 6. Now, they actually want dy dx, which means what do I actually have to do? Get it by itself. Good. So then to get it by itself, I probably would have moved everything else to the other side, which would have been a positive 3x squared y and then a minus y squared. I would have divided by, after factoring out a dy dx, my 2xy minus my x cubed. Does that look good to you guys? So far, so good? This is something like an AP FRQ that they would have said something like, show that the derivative is. But letter B, what does it have us do next? Okay, so to find the equation of the tangent line, don't I need y minus y1 equals m times x minus x1? Yes. Hopefully the plugging in of x1 was super easy. The plugging in of, m was a little bit nastier, and y was even a little bit nastier. So, what do we have to do to get here? Don't I first need to find my dy dx? Wait a minute, but to find my dy dx, don't I need x's and y? So maybe before I do that, how do I go get a y, guys? Plug it in back to the original. That original is useful information. So therefore I'm going to plug in my 1y squared minus 1y equals 6. What's the dilemma with this guy? Some of you would have started trying to factor and square root as is. Why did I move it all to one side? I need to go ahead and factor. And to factor, I need everything on one side. So I have my y minus 3 and my y plus 2. Therefore, my y is equal to negative 2 and 3. Why is that a struggle right now? Look at the wording. Doesn't that just open it up for there being more than one? My physics before, if there's more than one right answer, do you have to put both? Oh, we haven't done that yet? I think I had physics before this class. Oh, you did your FRQs today, so he hasn't talked about your multiple choice yet. Never mind. I'm not that smart. Coming back. Oh, well. Spoiler alert. Alright, so, don't worry, calculus. One answer and one answer alone on multiple choice. But FRQ, they left it open for there being more than one. So if you hadn't put both, you wouldn't have gotten all the points. Good news is it's a long answer, so you would have gotten partial points. But didn't we need to make 2 tangent lines? At both 1, 2, and at 1, negative 2, and at 1, 3. You guys see it? So then we need a dy dx at both of those different spots. So therefore we would have our first dy dx would be at, oh, I can't see it. There we go. We're just going to do mental math really quickly together to save on time. So I know, super dangerous. We would not do this on the AP. We would plug it in and we would take that whole nasty whatever with no multiplying, subtracting, or dividing, and we would put it in the m spot after you plug it in, right? But for simplicity's sake. All right, so if we plug in 1, we have 1 times negative 2 times 3. That'd be negative 6, yeah? And then we have minus positive 4, because a negative squared is a positive. Then we have all over. 2 times negative 2 would be a negative 4. And then we have minus 1, which isn't that big a deal, which will end up getting us a negative 10 over a negative 5, which is a positive 2. Good so far? Plugging in that other point, we would have 1 times 3 is 9, and then we'd have minus our 9. Awkward, but pretty sure that's true. Why am I still going, and why am I not just stopping? A 0 on top means everything's 0, unless we have a 0 over 0, and then if there's a 0 over 0. So therefore, I'm just going to plug in really quickly and make sure I'm good and make sure everything's working out right. So 2 times 1 times 3 would be 6 minus 1. Yeah, I'm fine. That's a 0 over a constant, which is just 0. True? So all I have to do is go ahead and set up my y minus. Uh-oh. What's my y1? Oh, never mind. No stress. I had a point. So y plus 2 is equal to a slope of 2 with x minus the x1. There's one tangent line, but I have another one. And then I have y minus my y1 equals my slope, which is 0. Oh, hey, no big deal. All right. But if you put the x minus 1, are you wrong? Then what's left? Letter C. So letter C, I guess I could keep scrolling down, but why not? We have space over here. So letter C. Find the x-coordinate of each point on the curve where the tangent line is. What does that mean? dy dx? Number over 0 for vertical. Vertical tangent line means a vertical slope, and a vertical slope means number over 0. Where the derivative is infinite. It's an infinite form, remember? Plus or minus infinity, check this out. Anyway, okay. So all you do is take the denominator. The denominator is 2xy minus x cubed equals 0. Wait a minute, what on earth do they want us to do? Hey, isn't there some homework like this? It says to find the points, and all I have is an equation. How do I find points if I have 2 unknowns? I better have 2 equations. Which I do. So I solve for my y, and I end up with adding x cubed and dividing by 2x, 1/2 x squared. Double check me, feel good? It's not enough to get me points, but if I combine that with, once again, didn't you guys tell me way back here, you plug in the x to the original equation, you need to go back to the original equation, true? Guess what? You gotta go back to the original equation again. So I can go ahead and take my y equals x squared and do a plug it in substitution deal. So substitution deal, every time I see a y, I'm going to go ahead and plug in my 1/2 x squared, minus x cubed, plug in my y, 1/2 x squared equals 6. Can I solve it? Didn't ask if you wanted to. Can we? Yeah. So therefore I have x to the 4th and x to the 5th, and I have a 1/4. So x to the 5th over 4, double check my math. Minus, I have x to the 5th over 2. Well, that's nice, because I can just do a common denominator real fast, right? Equals 6. So it's going to be 1x to the 4th minus 2x to the 4th, so negative, x to the 5th equals 6. Can't I multiply by 4 and get a 24 and divide by a negative, so a negative 24 and then take a 5th root? X is equal to the 5th root of negative 24. Are we right? Oh, yeah, we are. There was totally an AP FRQ back in the day that had something very similar to this. Maybe it wasn't that back in the day. Where are we at? Didn't say each point. I found the at, but I haven't found the point yet. That's just the x-coordinate. So my x-coordinate, I can technically pull out a negative if it was matching. It's totally not. It's an FRQ, but either way. Just allowing you guys or reminding you guys a negative can come out of an odd power. However, I need to go find my y, and my y would square it. Wait, squaring it, wouldn't that? Oh, not too much.
You don't have to find the y.
Did it say at each point?
It says x-coordinate.
Oh, never mind. Sorry, I didn't see it, so I just assumed. Thanks, guys, for writing it down and knowing. Could we have found the y if we needed to? Oh, who said no? Yes. I know, I heard that on too. Dun, 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 dun.
But if the other one be 0, because if you plug in, so it'll be the 2xy minus x cubed, you plug in 0.
So does that mean the danger is pause? What was in the word? As soon as you see each point, what does that mean? So what should we have done? How many of you guys like to add stuff to the other side and do stuff? How many of you actually tried to go, I don't want to say raising hands, but how many of you actually tried to factor as was with something on the other side? Why is it dangerous as soon as you start putting stuff to the other side? What should we have done? Question, would we still have gotten that y is equal to x squared over 2? But what else would we have seen?
What did I mention about going back to the original? I was going back to the original because I thought we needed to find the y. However, what's Lorenzo trying to point out to us?
What has to be true at the very beginning of the problem? So even though my plugging in the fifth root of negative 24 wasn't necessary, remember how a second ago I said, but could we find the y? And you said, yes. What's Lorenzo having us check? If we plug in a 0, can we find the y? So Kevin, should we have checked that x equals 0, or should we have been aware that x equals 0 could have been a possible x value?
Yeah.
Was it dangerous they asked us for the x coordinates at each point and didn't force us to go get the y's? Yes. Because is x equals 0 even a possible coordinate? Can we just see how letter C was maybe a little bit trickier than we thought? Because in a different AP problem, question, could there have been more than one point possible? Yes. In a different AP problem, could both points have been legal? Yes. So beware, beware, beware. Do you always have to do more than the question asks? No, but is it possible that by doing more, you figure out or you find legal versus illegal answers? Good working together, guys. So, our final answers, we have our A derivative, we have our B, 2 tangent lines, and we have our C. Hey, it could have been, now here's where the AP gets nasty. Ready? How many answers were there actually to letter C? But do you know what could have been in the FRQ scoring guidelines? A point for if you had canceled out or eliminated x equals 0. Which means you would have had to have written x equals 0, would have had to show plugging it in how it didn't work and saying x equals 0 was a possible x coordinate, but x equals 0 or the function in terms of 0 is not possible. Is that nasty? Yes. Have I seen them do it a lot? I've seen them do it once or twice. Those meanies. It's like, why didn't you just form a better question where both of the different x coordinates were possible points? I don't know. Maybe it was a mistake the once or twice that I saw it, but I actually saw them where there was only one specific answer, but if you hadn't eliminated another option, they would have given you the full points. Woo! That's mean. All right, cool kids, let's go grade. Here we go. Section 4.2. Section 4.2. Do you guys realize that I gave you a lot of AP hints last year in AB? But calculus was so new that a lot of them we just had to go over again when the AP exam was coming. But in BC, I'm giving you hints about the exam and the AP guide and former questions because you have so much more experience. Maybe some of them are sticky. And you're like, oh, I should watch out. Number 2. Oh my goodness, all of these. There's tons of work. Guys, can we just go to the very end and you guys ask about the ones you missed? Is that all right? Number 2, final answer is right here. 6y minus x squared. All over y squared minus 6x. Number 16. Here's your dy dx. Here's your dy dx.
However, this dy dx is only good, aka the derivative only exists, aka the function is only differentiable everywhere but where y equals negative 1/2 x, because they took that denominator and said, ooh, what if he equals 0? The derivative will not exist. They had to get y by itself, which is exactly what we did on the board a second ago. Vertical tangent lines, we got y by itself. Number 44a. Wait, what are we answering? Oh, there we go. A and C could be true. Thanks. There was something at the very bottom. A and C could be true. Could be true. Could be true. The other ones have contradictions. A and C could be true. Number 56. The desired point is 3, negative 1. Ooh, there was more than one option, but when you went the desired point was 3, negative 1 in number 56. Number 62, A. Number 62 was A. Number 64 was C. And then we're done. Alright, cool kids, I'm ready for homework questions. I'm ready for homework questions. For those of you guys that are bored, don't worry. Homework number 12 is in your Google Classroom, I'm pretty sure. You can double check. Let me know if it's not, and I can get it up there pretty quickly. But if you want to go play with section 4.3, if you're curious where we're going to derivatives of inverses, starting with trig. Or maybe just starting with inverse trig, and then talking about inverses, and then building up to inverse trig. Inverse trig is the grand culmination of this section. We talk about just inverse trig in general, and then derivatives of inverses, and then we put it all together. Anyway, if you want to go in Google Classroom if you're bored, but otherwise, does anybody have any questions on the homework? Yeah, Lainey. 55. Anything else? 30 what?
39.
Got it. Anything else? Are you sure? Wow. I thought that homework was going to be a little bit harder. Didn't have to be. That's okay. Okay. Let's get rid of whatever this writing is. If someone comes up with another one, let me know. But otherwise, we're going to 39 first and then 55. So 39, I think he was down here. Down here. There he is. Ooh, he was a square root of something with a square root. That's kind of fun. So you were just trying to find dy dx? Okay. So I'm finding dy dx. Question, what was your outside? Yeah, so I could think of, if you want to think of it this way, my f was square root of u, my u was 1 minus v, and my v was square root of x, if you want to think about it that way. Oof. Oof. Focus. Thank you. So that's for number 39, sorry. So if we're just trying to find the derivative, the nice thing is y is by itself, so it's not that huge a deal in the sense of I could go ahead and do it with chain rule. So I would get 1 over 2 square root of u, then I would get times negative 1 times v, which would be 1 over 2 root x. And I would have to go ahead and play with that and plug and chug what I know. So I would have 1 over 2 square root of 1 minus v times negative 1 over 2 root x. But I have to go ahead and plug in v, and v is square root of x, so that would be negative 1 over 4 square root of 1 minus root x, all times a root x, which I'm just going to put in front. Ugh. Okay. That's the explicit form where I have it totally in terms of x. But I have a question for you guys. Was there another form in the back of the book? That's an odd, right? That had x's and y's, or did it just have that one? Did it have x's and y's? For number 39? No. It looked like this? Yeah. Okay. There is another way that you guys could do it, where you don't have to do all that chain rule. Not that the chain rule is impossible and it totally gets you there. But the alternate way that you could have done it is you could have, let's see, squared the y, squared both sides, and gotten 1 minus root x. Anything else I think would have made it a little bit harder. But you could have rewritten it implicitly instead by getting rid of that nasty big old huge square root that's there. And then we could have taken the derivative, so it would have been 2y dy dx is equal to 1 minus root x. Then we could have gotten dy dx by itself by dividing this guy by that guy, 2y. And y to begin with, wasn't y to begin with 2 times the square root of 1 minus the square root of x. Now the dilemma is, if we did get, let's see, if we did take the derivative implicitly of that rewritten form, and if we did get dy dx by itself, and if we did plug in what y was to begin with, is this the exact same form? Yeah, exactly. It wasn't matching because I only took the derivative one side. I guess I'm tired. I guess I'm tired today. I'm sorry. Thanks though, David, for catching it. That was you, right? Well, here's the problem. If it's an FRQ, they're going to tell you what they want. It's going to be one of those, like, show that this is true. You know what I mean? And if it's a multiple choice, you'll know whether or not you're allowed to keep it with x's and y's or go just to x's. So that's why I asked what the back of the book had, because that's what we were trying to make it match to. You know what I mean? So now we can have it with dy dx is equal to, there's our 2 root x, and then we have another 2, which would make that a 4, and then we have our 1 minus. Okay, well either way you actually end up making it match pretty quickly. If you solve for your derivatives, right? Awkward. Okay, but that was number 39, we still have number 55. So could you have done F and U and V or F and G and H? Totally, you totally could have done that. But you also could have, oh hey, there's more light. You also could have gone about it the implicit way and just solved and then just plugged in for y at the end. Number 55, the folium of Descartes. Oh, 56 or 55? 55. Oh, that's okay, I got confused. Number 55, I thought that was the one that we had. Here, let me just take a picture of it. That'll make life a lot easier. So, 55 says, see the figure on page 164. Oh, he's way before. Find the slope of the folium of Descartes, and they give us the equation. Sorry, my little snipping tool is not coming up. Come on. Come on, come on. Come on, come on, come on. Computador. Let's go. Well, I don't know. Computer he doesn't really like, I don't think. I'm not sure he likes anything. I'm just trying. I'm trying to sweet talk. Nope. Alright, then I'll just write it down. So for the point of Descartes, the points for and okay, so we had to find the derivative at some point, right? What did you guys find for your derivative? Someone had this question. I'm assuming you started the problem because you were just taking an implicit derivative, right? That's easy cheesy stuff. So your implicit derivative ended up being dy dx equals? Cool. What's on the bottom? Can somebody back me in the answer? 3x. Okay, good. Now we're good? Cool. So then all we have to do for 4, 2, and 2, 4, we're plug and check, plug and check. I'm guessing that's not the problem. At what point other than the origin, oh, so they're saying the origin works. Does the folium have a horizontal tangent? Horizontal tangent, who knows setting equal to 0? Top. HTLs come from zeros of the derivative. VTLs, vertical tangent lines, come from zeros of the denominator. And like cusps and that sort of stuff come from 0 over zeros. So we can just say 3y minus x squared is equal to... Well, guys, okay, from what we just saw, we should probably be careful and try to factor. But can we factor this one? Not so good, right? Right? There's nothing to factor out and be wary of with the 0, so what's the only other way for us to go? Alright, so solve for y. So when we solve for y, we get x squared all over 3. Now, hold on. Why are they talking about the origin? Wait, they want points. What'd you learn from what we did at the beginning of class? How do we find points? You plug it back in because we have another equation. This isn't the only thing we know. We know this is true. So if we plug into that, doing letter D, I end up with x cubed plus x squared cubed would be x to the 6th all over 3 cubed, which is 27, right? And then we have minus 9x times the 9 and the 3 will reduce to just be 3. The x and x squared will become x cubed, and then, oh, the 3 reduced out, right? So that equals 0. Well, oh, no big deal. Can't I combine these? And I end up with negative. And then can't I factor out a common factor? So I have x cubed that can come out, and I have 1 minus 3 is negative 2, and then I have, so I have x cubed all over 27 minus 2, right? So I combine these ones to be a negative 2x cubed. I pull an x cubed from both of those, and I have negative 2 plus x cubed over 27. Negative 2 plus, got it. Why did I say other than the origin? Who's that guy? When x equals 0, who's this guy? When x equals plus 2 times 27 is 54, the cube root of 54, which I don't think is super nice, but we could rewrite it as what? If 3 times the cube root of 2? Isn't 3 cubed 27? So that can come out. Anyway, either way. Here's the struggle. Can I stop? No, because does it say at what x coordinate or at what point? Now we could double check the 0. Double checking everything in nasty AP, guys. But when you plug in 0, don't you get y equals 0? So the origin, okay, we can ignore this guy altogether. That was the whole origin clue. That's when x equals 0. But I also need to do when y equals 0. So we would go ahead and take this nasty dude and plug in. Oh, look, cubing 54, cube rooted is just 54, and then I keep going from there. Guys, did you find just one other point? Is that where we got stuck with solving for y? It's on the video if you need what we have. We know what we have, right? Right now we have y equal to the cube root of 54, or x equals. So we could go ahead and plug that in. And then some sort of feedback from people with questions. But maybe you got stuck a long time ago. You got stuck a long time ago. Isn't there a picture that we're allowed to look at, though? Yeah. That might make things a little bit nicer. Abby, what's that thing? Huh? Okay. This would be minus, we have y cubed minus, bring out the 327, cube root of 2y plus 54. Is that going to be a super nice to factor one? I don't think so. So I'm going to go ahead and go look at page 54 because they told us there was a picture for a reason, just in case there might be a helpful hint or clue. Page 164. You guys, you know that we're just looking for the leveling off points, right? So leveling off points at the origin, coming this direction, no, not this one. This one's the vertical tangent line, but coming this way, the horizontal tangent line is at 0, 0. You guys see there would be another 0, 0 right around here, right? True? That's the folium, right? I think so. Yeah, that's the folium. Okay, so going back to our question. How did you guys go ahead and solve for that y value?
Oh, I got rid of the y somehow. I said y equal to x squared over 3.
Oh, I just erased that. Thanks, Kevin. Bummer. how we found x was we had y is equal to, and we plugged in, right? We had two different relationships between y and x. Long story short, could you guys factor and solve for y from the original equation? No. But what did you have? That easy derivative. Sorry, my space is not really cut rough. So that relationship that we found from our derivative was y equals what now?
X squared over 3.
Over 3? So when we had our x equals the cubed root of 54, we could have just thrown it in right there. Which technically, once again, would have been, I guess, if it was multiple choice, 3 cubed root of 2, if you want to be all nice and particular. But either way, since we're not having to simplify the long answer, my y would end up equaling, I'm just going to go ahead and do cubed root of 54 squared. We don't have to simplify all of them. Thanks for reminding me that was a thing. Then letter C, find the coordinates of a point A in figure 4.7 where the folium has a vertical tangent. We would go ahead and take our denominator, right? We would go ahead and make y squared minus 3x all equal to 0. Once again, no greatest common factors to be wary of, so we could go ahead and solve. But in my head, isn't it a lot easier in this one to solve for x this time? So we get y squared over 3. And we could go ahead and plug and chug. But I'm pretty sure, isn't it also 0, 0? Does anybody find anything different when they went and plugged in y squared over 3 and solved for x? Did you not know how to do C? I'm surprised. Letter C. I'm trying to find a vertical tangent line so set the denominator equal to 0. None of us got it? 3 for both? Okay, I was looking at the picture quick, but maybe I read the picture wrong. So we would go ahead and plug in, and we would have y squared over 3. Anybody tracking with my set the bottom equal to 0? And we have x equals y squared over 3. Good so far? I've made mistakes today. Check me if I'm not. I have my y cubed. I have minus 9 times xy would be 9 over 3 is just 3. And then I have y cubed equals 0. Double checking, but I think I have a y to the 6th over 3. No, over 27. And then I have negative 2y cubed. Once again, I could go ahead and pull out my y cubed. And I would have y cubed all over 27 minus 2 equals 0. I would have my y equals 0, and then I would have my add 2 times 27 root 54. Find the coordinates at point A, figure 4.7. Yeah, so you get the x, and then that would be 0 again, right? 0, 0. There's the origin again by plugging back in, or by plugging in, and then we could plug into this guy and square him over 3. Find the coordinates at point A. Huh, that's weird. It says that there should be just 1, but I see 2, and it doesn't say other than the origin.
Isn't the origin horizontal?
Yeah, but the folium passes through it twice. So the initial, and then you have to find them. But we're not doing parametric equations, so maybe that's why it's saying it. You see the picture, right? Like it has a horizontal and then a vertical. Does the picture actually have like a little point A marked? Is that what I'm missing? That's not on the origin?
Yeah, there is.
Oh, there is a point A? Okay, sorry. Then it would be the other one. You would go find your x with a similar method that we just used. Okay, my bad. I didn't know they actually marked point A. If they marked point A, it was the one that was out, and the one that's out can't be the origin. The one that's out must be the other guy. Wherever page 164 is. Ah, look at him. He's right there. There he is. That's why we need the picture. Ba-doop. That can't be the origin. The origin's way over here. Okay. That was fun, cool kids. Good thing we're not having homework due tomorrow. However, I think we have just proven my point. Not my point. You didn't know I had a point, but I did. I was over here writing problems down. I was like, yeah, we should go over homework questions. I'm like, that's weird. I don't usually do this in BC. What don't I usually do? Homework questions. Guess who does homework questions? You do. And then I just provide guidance with the stuff. So, what would have made or helped today go a lot easier? Some of you had already worked through this. Some of you had worked through this in a way that you weren't trying to like fit stuff into this little tiny white space of a page, or trying to do problems without seeing the entire problem. You guys have worked through this and you've taken time on it, and some of you already knew you had it right. Perfect. You don't need me to start at the very beginning. So instead, when we have homework questions, here's what you're going to do from here on out. I'm going to write them on the board, and then I'm going to start handing them out for participation. Not extra credit, participation. So starting in grading period number 2, you get participation by taking homework questions. Now sometimes it's something where you're like, I want to take one, and I have it kind of done. I need someone to kind of be, with me. That might be a thing. Sometimes I put multiple people on the same problem. But we are going to start getting people up to the boards to cover homework questions because you guys can provide the work and provide the solutions that you already know is right, and then I can provide the explanation if you're stuck. Sound good? Oh well. Whether or not it does, that's the way it's going to go. Okay, here we go. So be ready. The next homework, the one that's due on Monday. We're going to take volunteers first, and if volunteers aren't ready, I'm going to look and see at someone who doesn't have any participation points. I'm going to call you up. And if you're like, ah! Then I'll let you call a friend with you. But if you get up to the board and you have nothing to do, what does that mean? You didn't do your homework. That's awkward. I'll sit you back down, give you a 0, and then move on. Give you a 0? 0 is a participation. Okay. We are starting off derivatives of inverse trig functions by just looking at inverse trig, not even derivatives. Inverse trig is trigonometry backwards, right? Inverse trig is trigonometry backwards, right? So what should this tell you? What do we need to know for this section? Unit circle, forwards and backwards. So maybe study your unit circle just a little bit and have it ready for me tomorrow. Tomorrow we're going to talk about inverse functions. Monday we'll talk about, well, this homework might be due on Tuesday. We'll see. Kiddos, your tests are graded. You can come and pick them up at any point today. If you'll pick them up today, I will give them to you tomorrow. Those corrections will be due soon. If you want points back, they'll need to be due after the weekend. We'll see. Yeah. I just want to be here so far. Does that work done?